Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad bin KHAIRI. My number is DE220154. So for this task, my group leader is giving my task is task 2, which is additional computation. So this task, it have 6 questions. So for the whole question, I will explain it. So this is the solution of the additional manual computation. So first of all, I draw the skirt. So from the skirt, I I have to find the 6 variable, which is VA, VB, VC, I1, I2, and I3. So VA from E1 and point B E1 until point B load. So VB, VC until B load, and VB is equal to B load. So VA plus B1 minus B load. So I get this answer 185.64 and angle negative 11.75. So B load 71.59. So angle is 34.99. So VC is equal to E2 minus V load. So I get 46.17 angle negative 129.08. So I want just Ohm's law. So using VA over XC, so I get 3.71 angle 77.24. So for the I3, which is I load, just V load over Z load. So I get 3.97 angle 91.3. So I2 from the positive to negative. So I get I'm using the current Kirchhoff law. So I2 is equal to I1 minus I3. So I get 974 milli angle 21.1 ampere. So for the omega formula is 2 pi f. So for the f frequency is 50. So for the omega is 100 pi. So for the first question is to find phasor domain and time domain for the I load. So I load from the circuit, I get for the phasor domain is 3.97 angle 91.3 ampere. For the time domain for I load is uh, using IP, which is IRMS multiplied with square root of 2. So I get 5.61. So in time domain, so in the form is using cos 5.9161 cos omega, which is 100 pi t plus angle 91.3. So for the next question is phasor domain and time domain for the voltage and current across inductor, so which is SL. So for the voltage in phasor domain, so to find the voltage across inductor, I'm using just Ohm's law, which is VIR, R exchange with SL. So I get the phasor domain is 43.83 angle with 68.9. So for the time domain, I'm using VP. So VP times to square root of 2, I get 61.98 volt. So in the time domain, 61.98 cos omega 100 pi t plus 68.9. So for the current across inductor, just uh, get from I2. So in phasor domain is 9.974 milli and angle negative to 1.1 ampere. So in time domain, I'm using IP. So time VRMS time to square root of 2. So I get 1.32 times 1.38 cos 100 pi t minus 2 to 1.1 ampere. So for the next question is phasor domain and time domain for the voltage and current across capacitor. So in the same method, I'm using Ohm's law. V equal to Iz. So Z is equal to XC. So I get for the phasor domain of voltage is 185.5 angle is negative 12.76, and for the time domain, I'm using VPIC 262.34 cos 100 pi t minus 12.76 volt. So for the current across capacitor, I'm using I1. So for the phasor domain is 3.71 angle 77.24. So for the time domain is 5.247 cos 100 pi t plus 77.24 ampere. So for the next question is draw the phasor diagram of the 3 questions above, 1, 2, 3. So for the first phasor diagram, which is I load against V load graph. So from this we can say that I load is lead B load. So next phasor diagram is current across inductor against voltage across inductor. So from the phasor diagram, I can say that is V across inductor is lead current across inductor. So for the capacitor is from the phasor diagram, I can say that is current across capacitor is lead voltage across capacitor. So for the same question, uh, I I uh, I need to draw the waveform. So this waveform I just get from the oscilloscope that I'm using multisim. So just copy from oscilloscope. So which is the waveform represent I load and V load. So this also represent by V and I, and also for in the capacitor uh, V and I. So we can see that I current is lead voltage. So for same goes different goes to the inductor that which is uh, voltage is lead current across the inductor. So the next question is to find maximum average power for the maximum value of Z load. So from the Z max, I'm using just in parallel formula. So I get 150 ohms. So for the voltage Thevenin, I'm using from the Thevenin theorem analysis. So I get 637.27 angle 85.46. So for the Pmax, I'm using formula VTH squared voltage Thevenin power of 2 and over 8 times R Thevenin. So I get 338.42 watts. So the last question is to find real power and reactance power absorbed by source 1 and source 2, the line 1 and line 2, and also the load. So this question must have 10 variable, which is 5 from real power and 5 from reactance power. So for the real power by the source 1, I'm using apparent power formula, which is S equal to VI conjugate. So for the source 1, I'm using V1 and V1 multiplied with I1 conjugate. Uh, So I get the answer of apparent power in the form of P plus JQ. So from this form, I get the power that observed, the real power that observed by source 1 that is 196.66 watt. So same goes to the source 2, same formula and same method. So I get the power absorbed by source 2 is uh, 25.02 watts. So for the real power absorbed by inductor is negative 13.88 watts. Same goes to the method, but to the source 1 and source 2 that I'm using. So because for the power power absorbed by the capacitor is zero because of that capacitor, the line 2 so don't have reactance, so that did not have real power. So for the payload, I'm using I squared multiplied with R. So I get 157.6609 watts. So for the reactance power, I'm using same goes to the real power method, is using apparent power formula S equal to V1 multiplied with I1 conjugate. So I get, so from this form, I can get the answer of reactance power, which is negative J8868.41 VAR. This is the unit of Q, the reactance power. Same goes to the reactance power absorbed by source 2, which is J15.09 VAR. So for the reactance power of inductor, I'm using formula Q equal to I2 square over XC. So I get the answer is negative J42.69. So for the capacitor, reactance power of capacitor is negative J688.205 VAR. For the reactance power of load is negative J286.41 VAR.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad from the HAMDAN and my number next week is DA22012. For this part, I will discuss about the vaccine, which is discussion FIA captive. But we should discuss about the manual competition result and analysis about the manual object of the calculation and the field. So there is a few additional manual competition must be obtained, which are the domain entitlement representation of the current, the domain entitlement representation for the voltage current for inductor, the domain entitlement representation for the voltage and current consider the diagram, also the average power, real power, and extra power. So we use the for the calculation we use the method which is superposition method to obtain the every value that we need. Right? First, first thing first, we should obtain the voltage on every node. which is VA, VB, and VC. So based on electrical knowledge, it is better to find this voltage, this negative, which is to find the voltage at VA, we need to subtract by the VB or the VA with VA. While for VC, we subtract the VC with VB. For voltage and VB, we can assume the VB equal to below. After we get the value of the voltage, we need to find the current, which is current I1, I2, and I3. To find this current, we need to go to the Ohm's law, which is V equal to IR to obtain the current at every branch. Then, after we get the current, we need to find the time domain, phasor domain, the variable to I or load, which is I3. After we obtain the domain, we need to find the voltage and current in inductor. Use the formula V equal to IR, which is V stand for the SL, VSL equal to I2 multiplied by the SL, which is the load in an inductor. After that, we need to convert the current and voltage to the time domain, which is Vt equal to 69.57 cos bracket 100 by t, subtract for 6.1 volt. For the current IT equal to 1.1 basic cos bracket 5 minus 36.4 ampere. So this we repeat this step to find the current and capacitor. To find the omega, we use the omega 2 pi which is 2 pi. 2 pi is a constant variable, whereas f is a frequency, the given integration. After that, we need to find the Pmax. The Pmax equal to the V Thevenin squared minus divided by 8 R Thevenin. But we need to obtain the V Thevenin and R Thevenin first before we can use the formula. So we can find the V Thevenin and R Thevenin we can find in the Z plus. So that we can substitute in the formula Pmax formula. For the last equation, to find the real power and reactive power, we can use formula of real power S equal to VI, whereas I will be the conjugate current and will be formed in P plus JQ. So we can use the formula to find the real power at the source 1, source 2, capacitor, inductive, and relay. The final answer will be in the rectangular box, whereas we have a real number and imaginary number. For the active power, we use the formula which is Q equal to AIMAN square multiplied by X, which is IM stand for the magnetic current and S stand for the load, capacity, and inductive. Then we substitute the value current and impedance to obtain the power for the capacitor, inductive source 1, source 2, and load.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHAHRIZAL, metric number DE220094. So this is present to you our simulation. So first I will show you how to obtain Vt and It for the capacitor and inductor, including phasor domain and time domain. But first we will get the phasor domain. So before that we have to replicate the circuit, and then after replicate the circuit we pick AC frequency and then pick 50 and then magnetic and phase. Then we go to output and then we select everything just like this, and then we click run. So after we click run, we will get the value of it. So as you can see, so this is for Vt at capacitor, and then this is the degree, and then that's it for the phasor domain. So next is time domain value. We get Vt, It. First we have to get the value of V peak and I peak for each one of this. So after that we use formula V peak or I peak times cos bracket 2 pi f plus the phase that we got from here. So we get this. So next is determine the phasor value of current and capacitor of inductor and load. So this is basically this thing. Okay, so next is how to get the waveform for the XC, XL, and Z load, and also where we get the V peak and I peak and time delay also. So to do this, first we have to change from single frequency AC like we did before, and then switch it to this, then save, then just run. Okay, so after run, first we do the XC, this, then we hit pause, then we scroll behind. So then we check this one, then we hit button Y max. So the Y max T2 262. So the V peak is 262, which is this one. And then to get the I peak at SC, we have to move this, and then we click on the waveform. So we go here, then we go to Y max. So it sits on the max of the I waveform. So the I waveform is So after NC, we do the Z load. So just like before, we just hit here, and then we click the graph, then we hit pause, and then we just go behind, then we drag this line, and then click so it go to the max. Then the next one, we click on this graph, which is represent the I waveform. So to get the IP, we click this, and then so now we get for the volt we get 100, which is near this one, and then for the high peak we get 5.6. So this is so to get the SL, we just repeat the same process that we have done this. So for the SL, we got this, and this. And for the time delay, we just got it from here. This is time delay, which is this. So that's it for me, and thank you.
Warahmatullahi wabarakatuh. So I will present about the question 3 that simulate the ZMAX and to get the value of power of ZMAX. So using multisim, we get the waveform from the oscilloscope. So this is the part of ZMAX, which is R equal to 150 and capacitor 212 microfarad. So this is the waveform of oscilloscope. The value of V is equal to 3.014, and for the current of ZMAX is 455.829 amp. So using the formula of P equal to VI, we can get the value of power ZMAX. So the value from the oscilloscope we pick. So we have to convert the value to the RMS value, which is 2 times to divide to set2, square root of 2. So we get the RMS value. So for the current value in RMS is equal to 322.320 amp, and for the voltage value is 2.131. And to get the answer of P, we multiply current and voltage, so we can get the answer is 686.864 watts. So that's all from me. Thank you.
Assalamualaikum. My name is Mohamad and my meter number is DE220109, and I will discussing about part B simulation. So for part B, we are using a multi-sim software to get the desired simulation values, which is VT and IT for the capacitor, inductor, and load values. So we can see here in the figure, multimeter XMM2 represent the value for the capacitor, multimeter XMM1 represent the value for the load, and for the multimeter XMM3 represent as the value for the inductor. So to calculate the voltage value, the multimeter should be connected to the capacitor, inductor, and load in parallel because each component has a different voltage value. So to calculate the current value, the probe is inserted into the line in series because the value of the current flowing through each component is the same. And next, so this is the table that we get for the value. And for the question 2, we also have found the phasor value of current and voltage for capacitor, inductor, and load. So by using frequency of 50 Hz, so this is the table for the summarize for the value. For the third question in this simulation, so for part B is we also found the value of the power of ZMAX by calculating the peak magnitude of voltage and the current. So we have built a circuit to find the power of ZMAX by using multi-sim software. So this is the result for the question 3. So for the peak magnitude for current is 455.829 ampere, and the voltage is 3.014 for voltage. So forget the RMS value, which the value for in peak magnitude, you should divide it by square root of 2, and we get 322.32 ampere, and the voltage is 2.131 voltage. And to get the power of ZMAX, we should multiply these two of values, which is 322.32 multiplied by 2.13, and we can get the values, which is 686.864. So that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad FIRDAUS bin Muhammad SUKI, matrix number DE220088. So today I will present about assignment for electrical circuit 2. So my part is for comparison and discuss part A and B. So here superposition analysis is a technique used in the circuit theory to determine the response of a linear circuit with multiple sources by considering the effect of each source separate. It is based on the principle of superposition, which states that the total response of a linear system in the sum of the response caused by each independent source acting alone with while the others are turned off. We need to find the voltage on every node in part A. So first, we need to find voltage on part A, which is calculation. So we can use simulation using multisim in part B. It will provide the graphical interface with values not so far from the calculated value in part A. So for part B, we use simulation to find the value. So for the value is not so far from calculation. So we can use simulation using multisim in part B. It will provide this simulation is where we need to create and analyze circuit, and it will obtain automatic by defining the nodes. So next, circuit theory serves as the foundation of the theory, and circuit modeling tools like multisim provide useful and effective way to apply this concept in practical manner. Engineer can experiment with various circuit layout, component, and parameter using circuit simulation tools, which act as virtual labs. Thus, it is simple to build and analyze complex circuit. While electrical circuit theory serves as a starting point for learning, multisim complete is by offering useful and effective means of putting putting this principle into practice. So by theory and practical application, we can see that the value V of time domain of XC is 262.34 cos 314.16 time minus 12.76 on calculation, while on simulation is 262.87. So it's not so far different from calculation and simulation. So next, for voltage for XL is 61.89, while on simulation is 62.01. So also not so far from calculation and simulation. So all these theories and practical simulation show that we can interpret complex circuit almost accurately. In the end, it optimizes the efficiency of circuit analysis and design procedure, resulting in the creation dependable and effective electrical system. So here is a table for time domain value for manual computation and simulation. So for XC is 262.64 simulation. So here for load is a little bit different. So next is for time domain. So for XC and SL it's not so far different, but for load it's a little bit different. So I think that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.